Passage 4. Physics students performed 3 studies to determine the forces that several doors exerted on their hinges. The doors that the doors had vicious weights W and width D. Each door had 2 hinges. The hinges could be moved to vary the distance S between them. None of the doors none of the doors had a doorknob. The 2 hinges on each door were equidistant from the center of mass of the door. See the diagram. There's a diagram there. Each hinge was fitted with 2 force sensors, with the door attached to a door frame. One of the sensors detected the horizontal force exerted by the door on the hinge FH, and the other sensor detected the vertical force exerted by the door on the hinge FV. Once FH and FV were determined for each hinge FH was averaged over the 2 hinges, yielding average horizontal force per hinge FH, and FV was averaged over the 2 hinges, yielding the average vertical force per hinge FV average. From FH average and FV average, the average net force per hinge Fn could be calculated. In the 3 studies, all forces were recorded in pounds lb, and all lengths were recorded. Study 1. For a door with W equals 61 pounds and D equals 30 inches, the students determined FH average and FV average at various S. The results are shown in figure 1. There are the results. Study 2. For 3 doors, each width D equals 30 inches, but a different W the students determined Fn average at various S. The results are shown in figure 2. Figure 2 shown below. Study 3. For 3 doors, each width W equals 61 lb, but a different D, the students determined Fn average at various S. The results are shown in figure 3. They're the results. Okay, so which of the 3 types of problem is this? This is research summary, as research was conducted and graphs shown here. Study 1, Study 2, Study 3, the studies are research, and that is the type of problem this is. Now let's look at another problem. Passage 5. In a chemistry class, the teacher placed 0.5 grams of porous steel wool, composed mostly of iron, Fe, inside small heat-resistant quartz tube. She then used silicone hoses to connect the quartz tube to 2 airtight glass syringes. See figure. Each syringe contained 8 milliliters of air, and the total volume of air in the closed apparatus was 20 milliliters. See the figure below? Figure adapted from Francisco Vera, Rodrigo Rivera, and Cesar Nunez. A simple experiment to measure the contents of oxygen in the air using heated steel wool. Copyright 2011, blah, blah, blah. A Bunsen burner was then used to heat the contents of the quartz tube for 2 minutes. During heating, the plungers were moved up and down to pass the air back and forth through the steel wool. The total volume of gas in the apparatus steadily declined over the 2 minutes. Once the apparatus and its contents returned to room temperature, the total volume of gas in the apparatus was 16 milliliters. The teacher asked each of 4 students to explain what occurred during the demonstration. Student 1. During heating, the iron in the steel wool reacted with all the nitrogen gas in the air to form solid iron nitride, FeN, which was deposited on the steel wool. Air contains about 20% nitrogen gas by volume. As a result of the reaction, the total volume of gas in the apparatus decreased by about 20%, so almost all the gas remaining in the apparatus was O2. Student 2. During heating, the iron in the steel wool reacted with some of the O2 in the air to form solid iron oxide, Fe2O3, which was deposited on the steel wool. Air contains about 80% oxygen by volume. As a result of the reaction, the total volume of gas in the apparatus decreased by about 20%. Almost all the gas remaining in the apparatus was a mixture of about 75% oxygen and 25% nitrogen by volume. Student 3. Student 2 is correct, except that the Fe ion in the steel wool reacted with all the oxygen in the air, and 2, air contains about 20% oxygen by volume. After the reaction, almost all the gas remaining in the apparatus was nitrogen. Student 4. During heating, the iron in the steel wool reacted with all the carbon dioxide in the air to form solid iron carbonate, FeCO3, which was deposited on the steel wool. Air contains about 20% CO2 by volume. As a result of the reaction, the total volume of the gas in the apparatus decreased by about 20%, so almost all the gas remaining in the apparatus was O2. Okay, now what type of problem is this? Well, we see here that student 1 through student 4, neither of them have points that necessarily agree with one another, at least not in every single way. So these are conflicting viewpoints. The viewpoints with each of what they solved and what they got as a result conflict with one another, and we need to figure out how to interpret the result that they got from this experiment. Okay, let's move on to the final problem. Passage 6. Quarks constitute one of the three classes of elementary particles that form all matter in the universe. Three quarks bound together form a type of particle called a baryon. A quark's effective mass when bound to other quarks is greater than its single quark mass when unbound. In addition, all quarks possess a property called spin. A quark's spin can be oriented in one of two directions, spin up or spin down. Table 1 lists the symbol, electric charge, and approximate single quark mass for each of the 6 quarks. There's table 1 there. Table 2 gives the symbol, mass, quark content, and quark spins for several baryons. Table 2 shown that. Okay. Now, which of the 3 types is this? Well, seeing as we had research summary and conflicting viewpoints occur twice, the third academic type must have its type shown here, which was data representation. We see here a table in data 1 and table 2, and your job as a student is to interpret what table 1 and table 2 both mean in answering the questions. Now let's do one of the problems. Now let's do one of the problems and sample how to get the answers.